In part 3 of the Unit 3 notes, we are going to be counting protons, neutrons, and electrons for atoms. The atomic number is a small whole number shown on the elemental symbol of every periodic table. It is equal to the number of protons, or +1 charge, present in each atom of an element. The atomic number defines an element, so no two elements will ever have the same number of protons. For a neutral atom, there must be an equal number of electrons, or -1 charge, in order for the charges to cancel out. So here I have an example of what you would see on your periodic table for the symbol for helium. The number on the top here, the smaller of the two numbers, is the atomic number. So based on this information, I can tell that helium is always going to have 2 protons. And if this is a neutral atom of helium, it will also have 2 electrons, since those 2 subatomic particles would have to cancel out. Now, depending on which periodic table you are looking at, sometimes this number will be listed on the bottom instead of the top. So you shouldn't necessarily memorize the location. It is always going to be the smaller of the two numbers, and it will always be a whole number. Next up, we have the mass number. The mass number is equal to the number of protons and neutrons for an atom. Always check to see if a mass number has been given to you in a problem first. If you are not given a mass number, you can approximate it by rounding the average atomic mass to the nearest whole number. So for example, if I wanted to know what the mass number of helium was, and I wasn't given any other information except for the fact that it was helium, I could look at this symbol on the periodic table and take this average mass and I would round it to 4, since that's the nearest whole number. And I could say, okay, there is a total mass of 4, which is the protons and neutrons together. Now, a very common misconception for high school students is that they think that this mass number is just the neutrons, since we have a proton number here. There is no neutron number on the periodic table, so you would have to do a little bit of math if you wanted to figure out how many neutrons were inside of the atom. This is the periodic table that you will be given in class. So you will be able to find a digital version of this posted to Google Classroom under resources for the current unit. All right, let's say that we want to count up the number of protons, neutrons, and electrons for a neutral atom. In this example, we are trying to find that information for boron. We are also told that the mass number is 11. So if you're ever given a mass number, you want to ignore what's on the periodic table, because sometimes, for reasons which we're not going to get to quite yet, that number may be different. So we have a mass number of 11, and we have an atomic number of 5. And here, we're actually just trying to find the neutrons. So if I know my protons and neutrons together are going to be the mass number of 11, and I subtract away my number of protons, which is the atomic number, 5, 11 minus 5 is 6. So there is math involved, but definitely not complicated math. Now in our second example here, we are asked how many neutrons are in carbon. Now this time they didn't give us any extra information. There's no numbers here. So what I would do is look at a periodic table, and I've included a screenshot of the symbol for carbon here. I'm not given an actual mass number, but I can approximate it based on this average atomic mass. So since this mass is very close to 12, I'm going to round that to 12. So I have a mass number of 12. The atomic number of 6 is equal to my protons, so 12 minus 6. And since I subtracted away the protons, all that's left are the neutrons. So there would be 6 neutrons inside of this carbon atom. All right, now for our checkpoint. You need to determine the number of protons, neutrons, and electrons for each of the following neutral elements. You're going to have to estimate the mass number by rounding the average atomic masses, because you are not told what the mass number is for any of these. We have each of the symbols here so that you don't have to try to track them down on a periodic table. Now I will solve each of these, but at this point, I highly suggest that you pause the video and try to fill this in on your own in your notebook first, and then check your answers after. So you should pause now. All right, so I am going to start by filling in the atomic number for lithium. It's the number which is on the top, is the smaller whole number, so my atomic number is 3. My mass number, I'm going to round from the 6.941, so that would round up to 7. Protons are always equal to the atomic number, so that's 3. Now at this point, I need to subtract. My neutrons are solved by getting the mass minus the atomic number, so 7 minus 3 is going to be 4, and my electrons are 3. All right, for gold, the atomic number is 79, the number on the top. My mass number is 197, so that 9 would round up to 6. My protons are 79, since the atomic number is always equal to the protons, and I'm going to need to subtract these two numbers in order to find the neutrons. And if you need to, you can use a calculator for that part. This is going to be 118. For our last part, since this is a neutral atom, it doesn't say anything about having a charge, our electrons are also going to be 79, so that these two are equal and they cancel each other out. Phosphorus, we have 15 for my atomic number. The mass is going to round from 30.97 to 31. Protons are 15 because that's the atomic number. I'm going to subtract these two for the neutrons, so 16. And then protons and electrons are equal, 15. For our last one, we have calcium. Atomic number is 20. Mass number is 40, because the 0 will not round up the other 0. Protons are 20. When I subtract, 40 minus 20 is also 20. And then 20 electrons to cancel out the 20 protons. So for this one, our protons, neutrons, electrons are all equal. That concludes part 3 for our Unit 3 notes. When we come back for part 4, we will be drawing Bohr models.